Hello everyone, this is the North America Math Contest Go Go Go. This week we are going to do another problem. Consider the differential equation x squared minus this. Let's see the first problem. Second derivative in terms of x and y. So dy qx minus this y dy over dx, which is equivalent to 2x minus 1 over 2 dy by dx, which is equivalent to 2x minus 1 over 2 x squared minus this. So we get the first problem. Let's now see the second problem. Let y equal to fx be the... So does the graph of f have a relative minimum, a relative maximum, or neither as a point? -2, 8. So let's see this problem. So to solve this problem, we need to check whether it has a critical point at here, whether this is a critical point or not. If this is not a critical point, we can immediately say there is no any relative minimum or maximum. So we first see the what's that called? The critical point, which is dy is equal to -2 squared minus this, which is equivalent to 0, which means it has a critical point. So this means that we can check whether it is a relative maximum or minimum. If it is larger than 0, then it is a minimum. I mean, if the dy dx squared is larger than 0, then it is a relative minimum. If it is less than 0, then it is a relative maximum. If it is equal to 0, then it's harder to decide. So let's start with it. We already know the equation at here, so this means we can just plug in the value directly. Is equal to -4. -4 is less than 0, which means it is also okay. So after this, we can get that it fits the two criteria, which means it is a relative maximum at the point -2, 8. Done. Now let's see the third problem. Now let's look at the problem C. Let y is equals to gx to be the particular solution with the following differential equation of this. We are required to find this formula, which is -2 and 3x plus 1 squared is 0. So let's do the first differentiation first, which is lim x -1 g -1 minus 2. This is based on the L'Hopital rule. So the L'Hopital rule states that if lim fx gx is equal to 0 to 0 or infinite to infinite, then the result is fx g root g derivative x. So we find that -1 square -1, so this fits 0 to 0, right? After that, we can just calculate. After that, this is our first transformation after the L'Hopital rule. This is our first transformation after the L'Hopital rule. So let's apply the L'Hopital rule here, which is lim x -1 gx 6x plus 1, the both derivative. However, you still can get nothing from here. So you need to do another L'Hopital rule. But before we do the L'Hopital rule, we need to check whether it is 0 divided by 0. So this part, -1 plus 1, it is definitely 0. So then this part is gx. So since the gx, it is referred to dy over dx, and then we need to check it. We need to check based on this one. So dy by dx is equivalent to x squared, where x is -1 minus 1 over 2, which it is stated here. So this means that dy over dx, which is gx, is 0. So this means that the L'Hopital rule can be applied. Gx. And then the result is this. The second application, after the second application of L'Hopital rule. So to do that, we need to calculate the g double x, which is d2y over d squared x. Remember, it is equivalent to 2x minus this dy over dx. And we know that the dy over dx is 0. So we only need to calculate the 2x. The 2x, since x is equal to -1, as I stated, as the problem stated above at limit. So this means that this is equal to -2, and the result is equal to -1 divided by 3. After we have completed problem C, let's work on D. Let y equal to hx be a particular solution to the given differential equation with h0 equal to 2. Use Euler's method. Starting at x as equal to 0 and approximate h1. Just recall this formula here. Now let's do problem 4. To do problem 4, the Euler method, we must list out a chart, which is x, y, dy over dx. dy is equal to this times steps. And the steps for x is 0.5, which is 0.5. Okay, so it is 0.5, 1. Since we are required to estimate h1 with the steps of 0.5. So, as the problem given us, the y is equal to 2. So we can then use this to calculate dy over dx, which we get that the result is -1 here. dy, this is -1 and the step is 0.5, so the result is -0.5. After that, we minus y by this, which we get 1.5. And then we calculate dy over dx again. Let me think. 0.25 minus 0.75 is equal to -0.5. And then we calculate -0.5 times step, which is 0.5, is -0.25. And then we minus this by this, and we get 1.25, which is our final result. So we can draw a conclusion that h1 is equal to 1.25, and we come to the end. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye! In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!